Hello, welcome again. We are covering the subject thermodynamics for civil services means IFS and various gate exams. The next topic in the chapter of availability is useful one. So in the previous videos we derived the expression for maximum work done for steady flow system as well as for closed system. Okay, and in that we did not consider the work done against atmosphere. Okay, so while executing the process the system also changes its boundaries against atmosphere, so it has to do some work against atmosphere, so we have to uh, take this work into account also. Okay, so suppose this is the system initially, or initial volume of the system, or initial boundary of the system, and this is the final boundary of the system. Initial volume is v1 and final volume is v2. So the useful so the work done against the atmosphere will be at P naught V2 minus V1. Okay, so useful work will be your actual work that is obtained from a process minus work done against atmosphere. So that is useful work. Or maximum useful work will be your WU max is equal to W max minus P naught P naught bracket V2 minus V1. Okay, or in differential form it can be written as dw max is equal to dw max minus p naught dv. Okay, so in case of steady flow these boundary will not change. Okay, this boundary remains same, so there will be no work done against the atmosphere, so useful work will be equal to maximum work. Okay, but in case of unsteady flow there is change in energy of the control volume and the boundary also changes, so the expression will be this. Okay, so now if we put the value of dw max that we obtained in the equation number 7 here, sorry here, this value, if we put here this value, then the expression for dwu max will become dm1 h1 was there initially, t naught s1 was there, v1 square was 2 was there, plus gz1 was there. So this is the input uh, section and this is output section, and in this we will introduce this because dv is there, so we will and minus sign is there, and there was minus sign is already there, so we'll put minus minus plus, so we'll add here plus p naught v. We'll change this, we'll change this part because here u minus t naught s plus mg square by 2 plus mg z was there, so and in this we have minus p naught dv, so we add here in this part p dot v, then it will make dwu max. Okay, because p naught is constant quantity, and if we take it out of the bracket, then will be p naught dv minus p naught dv, so that will be same. Okay, after putting dw max. So this will be your maximum useful work in case of unsteady flow system. So now we consider closed system, and in closed system differential work was this quantity dwu max was this quantity, and then here again we will add p naught v in this part, so it will become minus d bracket u plus p naught v minus p naught s plus mg square by 2 plus mg z. Okay, or this will be this can be written as u plus mg square by 2 plus mg z can be written as e. Okay, or opening it or differentiating it will give maximum useful work, that is E1 minus E2 plus P naught V1 minus V2 plus minus T naught S1 minus S2. Or if we neglect changes in kinetic energy and potential energy, then it will be U1 and U2 here only in place of E1 and E2. And now this expression can be written as U1 P naught V1 minus P naught S1 minus U2 plus P naught V2 minus P naught S2. So this is your availability function for closed system. We have already studied the availability function for steady flow system. So that was this quantity H1 minus T naught S1 plus MV square by 2 plus MV Z1. Now it is availability function for closed system. The difference is here U is there and here H was there, okay, and here MV square by 2 mgz was there and T naught S was there. So here there is no kinetic energy or potential energy, because in closed system there is no kinetic energy, so just difference is this, and that's why U is also there in place of H. So this is your availability function for closed system, okay. So now this is your useful work. Now we will do one more article, that is maximum useful work obtainable when the system exchanges with thermal reservoir in addition to an atmosphere. Up to now we have studied that maximum useful work that is obtained when exchanged with atmosphere only. Now we will take a thermal reservoir which is also adding or injecting heat to the system, okay. So if thermal reservoir is connected to the system, then the reversible work that can be obtained from the system is from this thermal reservoir is QR bracket 1 minus T naught by Tr. So what we will do, we will find out the useful work just by adding this. For steady flow system, we will take psi 1 minus psi 2 and this quantity, and for closed system we'll take pi 1 minus pi 2 and this quantity, okay. So that is the difference. Rest of the things are same, and just you have to remember availability function for steady flow system and availability function for closed system, okay. So this is the difference. Here H is there for steady flow, here U is there, and here this part, because mv square by 2 and mgz is there, and here this p naught v is there, okay. So these are the difference.